To some people, these symbols look like a secret code, a wall, something scary. But these symbols are one of the most powerful tools the human mind ever invented. You already think in algebra every single day without even knowing it. By the end, you won't just know algebra, you'll understand it. Imagine you have some cookies. You can see 3 of them on the table. But there is also a closed box, and you don't know how many cookies are inside. Your friend says, altogether you have 7 cookies. How many are hiding in the box? You probably whispered it already. 4, 3 you can see plus 4 hidden makes 7. Congratulations, you just did real algebra. Algebra gives that mystery a name. Instead of a box, we use a letter, usually x. Then we hunt it down with logic until x equals 4. Arithmetic asks, what is 3 plus 4? Algebra asks, 3 plus something is 7, what's the something? Arithmetic gives answers. Algebra gives the power to ask better questions. Where did the word algebra even come from? The story is wonderful. Over 1,000 years ago, in the House of Wisdom in Baghdad, lived a scholar named Al-Khwarizmi. Around the year 820, he wrote a book containing the Arabic words Algebra. Algebra means the reuniting of broken parts, restoring balance across an equation. That single phrase traveled across centuries and became our word, algebra. And his own name, passed through Latin, became another word you use every day, algorithm. Every app, every search engine, traces its name back to this one mathematician. If you remember just one idea, remember this. In algebra, a letter is not really a letter. It's a container, a box that can hold any number at all. We call it a variable because the value inside can vary. It can change. The opposite of a variable is a constant, a number that stays put like the 3. Why letters? Speed, and because we can track many unknowns at once. Once you can name the unknown, you can reason about it, even before you solve it. Now let's build. Combine numbers, variables and operations and you get an expression. 2x plus 5 means, take x, double it, then add 5. A recipe waiting for an ingredient. Pour in x equals 4, and the recipe produces 13. Pour in x equals 10 and you get 25. Same recipe, different result. In 2x, the 2 is the coefficient, the x is the variable, and the 5 is a constant. When a number sits next to a letter, there's an invisible times sign. 2x means 2 times x. An expression has no equals sign, an equation does. We simplify expressions, we solve equations. Picture a balanced scale. This is the most useful image in all of algebra. An equation is a scale that is perfectly balanced. The left side weighs the same as the right. Here is the golden rule. Whatever you do to one side, you must do to the other. Add 10 to the left, you must add 10 to the right. Balance restored. Our mission every single time is to get the variable all alone. We call it isolating the variable. Let's solve one slowly. X plus 3 equals 10, we want x alone. To undo plus 3, we do the opposite. Subtract 3 from both sides. The plus 3 and minus 3 cancel, and x is left standing alone. X equals 7. Always check, 7 plus 3 is 10, it works. Every operation has an opposite and undo button. Addition undoes with subtraction. Multiplication undoes with division. 4x equals 20. Divide both sides by 4 and x equals 5. Now 2 steps at once. 2x plus 5 equals 13. Undo the plus 5 first. Subtract 5, leaving 2x equals 8. Then divide by 2. X equals 4, exactly the cookie answer from the start. Sometimes x appears on both sides. 5x plus 2 equals 3x plus 10. Gather the x's on one side. Subtract 3x, giving 2x plus 2 equals 10. Subtract 2, divide by 2, and again x equals 4. The same moves over and over. Before we go further, we need the rules of the game, the order of operations. 3 plus 4 times 2. Left to right gives 14, but multiply first gives 11. Two different answers is chaos, so mathematicians agreed on one fixed order worldwide. Parentheses first, then exponents. Then multiplication and division as a team, left to right. Then addition and subtraction, left to right. Some call it PEMDAS, some BODMAS. So 3 plus 4 times 2 is 3 plus 8, which is 11. A meteor 1, 2 plus 3 times 8 minus 5 squared. Parentheses first, 8 minus 5 is 3. Exponent next, 3 squared is 9. Multiply then add, the answer is 29. You can only add things that are the same kind. 3 apples plus 2 apples is 5 apples. In algebra, the variable is the kind of fruit, so 3x plus 2x is 5x. But 3x plus 2y can't combine, they are different variables. Even x and x squared are different species, the power changes the kind. The distributive property shares the outside number with everything inside. Watch the sign, -4 times the group hits both terms. Algebra lives on a number line running both ways. Right of 0, positives, left, negatives. Think of an elevator. 0 is the ground floor, positives go up, negatives go down. Negatives are real life, temperatures below freezing, money you owe, depth below sea level. A negative times a negative is a positive. The opposite of the opposite brings you back. But a negative times a positive stays negative. Master your signs, and you remove the number one cause of algebra errors on the planet. Now algebra earns its keep. In real life, nobody hands you the equation, just a story. So we translate is becomes equals, more than becomes plus, times becomes multiply. A phone plan costs $20 plus 2 per gigabyte. This month the bill was $30. Subtract 20, divide by 2, you used 5 gigabytes. 4 friends split a bill plus a $12 tip, paying 20 each. Find the bill. Multiply by 4, subtract 12, the bill was $68. Sarah is 3 more than twice her brother's age, and Sarah is 17. Solve it, the brother is 7. Every word problem is an old friend in a costume. Let's add a second dimension and connect algebra to pictures, the coordinate plane. Descartes dreamed it up while watching a fly crawl across his ceiling. Every point has an address, 2 numbers, how far across then how far up. The point 3, 2 means 3 to the right and 2 up. An equation with x and y describes a whole family of points, a shape. Plot them all and they form a straight line. The picture and the formula are the same idea. Straight lines are so important, they have their own beautiful formula. B is the y-intercept, where the line crosses the vertical axis, its starting point. M is the slope, the steepness measured as rise over run. A big slope is steep, a negative slope goes downhill. A zero slope is perfectly flat. Slope is rate of change, speed is slope, price per item is slope, it's everywhere. Your phone bill was a line all along. Cost equals 2 times gigabytes plus 20. 1 grain of rice on the first chessboard square, doubling on each square after. By the 64th square, the king owes more rice than exists on all of Earth. That explosive growth is the power of exponents. An exponent is a shortcut for repeated multiplication. 2 to the 5th is 5 2's multiplied. X squared is the area of a square. X cubed is the volume of a cube. Multiply powers with the same base, add the exponents, divide and subtract them. And here's the delightful surprise, anything to the power 0 equals 1, always. Stack terms with whole number powers and you build a polynomial, many terms. The highest power is the degree. Degree 2 gives a U-shaped curve, a parabola. Factoring is the reverse of distributing. Find the pieces that were multiplied together. Find 2 numbers that multiply to 6 and add to 5, 2 and 3. If that product is 0, one bracket must be 0. So x is -2 or -3. Those are exactly where the curve crosses the x-axis. Picture and algebra hand in hand. Sometimes a quadratic won't factor nicely. For that, one universal key unlocks them all. The quadratic formula. Feed it any equation in the form x squared plus bx plus c equals 0. For x squared plus 5x plus 6, a is 1, b is 5, c is 6. Plug in and you get minus 5 plus or minus 1 over 2. The plus or minus gives both answers at once, minus 2 and minus 3. The part under the root, b squared minus 4ac, is the discriminant. It predicts the answers. A system is two or more equations working together, two unknowns at once. Graphically, the solution is simply where the two lines cross. It's how a GPS finds you, and how stores find their break-even point. Inequalities use less than and greater than, ranges, not single points. Solve them like equations with one twist. Dividing by a negative flips the sign. Not 1,000 rules, a handful of beautiful ideas used again and again. Remember how these symbols looked like a wall, now you know what they mean. The wall became a door and you walked through it. If a child can find a cookie hiding in a box, they can do algebra, and so can you. Practice a few problems on your own. That's where understanding turns into power. Until next time, keep finding the cookie in the box.